stopped around here, right? The idea was to take the people who had volunteered to be in our study and randomly assign them using basic block randomization into the different groups. Right? And then you're going to calculate the means for each condition. So now everybody could have done this a slightly different way, but let's back up and just do it one way and see how it comes out. And then if you did it a different way and you're concerned that there might be an issue, let me know. But some variation is fine, right? Because if you do random assignment, you pick different random orders. If you pick different blocks, you're going to get different numbers. Okay, so what blocks should we put here? Somebody give me the first block.
A, B, C.
Okay. Okay, what here?
BCA.
Okay, and here?
CAB.
Here?
BAC. CA. ACP.
So I assume this is what we wrote last time, so everybody just did it exactly the way we did it in class? Okay, so if everybody did it exactly the same way, we should all have the exact same numbers in each of these columns, right? Okay, so we're looking at the first three people coming in. A, B, C. Person 1's going to go in A, person 2's going to go in B, person 3's going to go in C, right? Okay, so tell me the weights. For program A, what number goes here?
313.
Okay, and here?
325.
Huh?
256.
It can't be 325, that's more than 313.
Oh,
Huh?
I made a typo. 256.
256 is the second heavy. 256, okay, and here?
288.
288. Okay, does everybody have that? And you know where it came from? Okay,
Oh,
we're going across.
yeah, never mind.
Because we're applying this block and the block applies across. That make sense? Okay. I just want to make sure everybody knows where the numbers came from. So we want to apply them across because we're going to apply them across each day. Okay, what's our next row? Program A? 262, okay.
47.
247.
277.
277?
Yes, ma'am.
Okay. So polite. Abby's always so polite. Yes, ma'am, no, ma'am. Being in the South is so great. Of course, I remember when I first moved here, people said, yes, ma'am, and I'm like, ma'am is my grandmother.
Dr. G.
No, I'm old. So I'm like, bring on the ma'am. Okay, that works. All right, next one.
280.
280.
292.
Okay,
300.
okay, here.
253. 293. 301.
We've all just nominated Abby to be the voice of the class. That's all right. You are officially nominated. Okay, if anybody disagrees with what she says, you better shout out because she's, yeah.
I think that second row, is that wrong?
The
'Cause I
second
got-
row, BCA. That means
Yeah.
the first person who comes in goes to B.
Yes, 277. Wait, how do we do it? I don't get it. Mm-mm.
Okay, so let's back up a little bit. Make sure we understand what's happening. I'm going to pull this down so that I don't have to erase the board. See, look at it's almost like science. Okay, so the first three people, 313, 256, 288, right? Okay. So that means if our first block is A, B, C, this person goes in group A, this person goes in group B, this person goes in group C. Okay? With me so far? Okay, and what was our second block?
BCA.
BCA. That means this person goes in B, this person goes in C, this person goes in A.
Oh, wait.
If our second block is BCA,
Okay.
okay? You with me?
Mhm.
Our second block is BCA.
Okay.
That means the fourth person goes in B, the fifth person goes in C, the next person goes in A.
Okay.
It's learning, it's happening right here. Yes. All right, so what's our next block?
CAB.
CAB. CAB is our next block. These are just the ones that we picked last time, so we're just using the ones we picked last time, okay? CAB was our next block, so that means this person goes in C, right? 300 goes in C, 280 goes in B, 292 goes in A. Is it CAB? Oh, CAB? Is that our order? Sorry.
CAB.
That's too many blocks. I can't get them all straight. CAB. So 300 is C, 280 is A, 292 is B, right? Okay, so that's how we're doing it. We're looking at how they came in the door, right? And then, move this back up. Yay! Like it just all of a sudden fits. I love that. All right, so then what we're doing is we're just picking the block and we're using that block to assign the people off the list. Okay, so now we're doing order CBA. We're down to the last 6 people on the list. Okay, so CBA in program A, what weight do we have? 269. Okay, and in B, what do we have? 311. Okay, and in 275. Okay? And now we had the last 3 people. Right? Last 3 people, A, C, B. Okay? So, who goes in, what's the weight for A?
190.
And what's the weight for B?
215.
And for C? 234. Okay, so in this box, you're going to have something like, okay, so I assign the blocks, and then I use the blocks to decide what order I would assign the people to the condition. So if my block was A, B, C, the first person went in A, the second person went in B, the third person went in C. If my block was B, C, A, the first person went in B, the second person went in C, the third person went in A. And the reason that I ask you to do that where you write it out in sentences is because it helps you organize in your head what you're doing. If you can describe what you did in a sentence so somebody else can do the same thing, then you probably get it. But if you say, I don't understand how we got, I don't know, I just kind of put the people in the blocks, then you might not understand what you're doing when we get to the test. If I give you some instructions to do this, you might not understand what you need to do. You might just start putting everybody A, B, C, A, B, C, A, B, C, A, B, C, or something like that. Don't do that. Okay, so if we do this, the next question was, if we calculate the means for each of these groups, what do we get? So if everybody who has these same numbers should have the same means, right? Okay, so let me erase this now. Everyone's okay with these numbers? Recognize, if you use different blocks over here, then your numbers in that part are going to be different, and that's okay, as long as your procedure was the same. As long as you selected blocks and then used those blocks to assign the people to groups, you're in good shape. Okay. So now our next question is, what were the weights, the average weights for the 3 groups? So for program A, what average weight did the people get who used those numbers we just put on the board? 265.0? 265.0?
I got 262.5, so
That's what I got.
263.
262.5?
Do you want us to round it off?
We round to 2 decimal places in this class. Always to 2 decimal places would be 265. 262.50. Okay, since the second digit is 0, we'll just drop it off. Okay, so that's what, how many people got 262.50 for those numbers we posted on the board? Okay, so that's math by consensus. That's how we do it in here. If multiple people agree that an answer is right, then that's the one we go with. Now my question is, if you use those same numbers, can you double check your math to make sure that we got it? Because I want you to double check and make sure that we know where that extra, did you maybe use a block in a different place or something like that, or was it exactly the same blocks in the same order? Okay. So what I would do is I would add those up and divide them again. And you got the same? You got it? All right. See, this is why we do it, so that we can, and if you get something and your neighbor doesn't get it, help. Because at some point, you won't get it, and they will get it, and they will help you, right? This is a collaborative effort when it comes to learning. It's an individual effort when it comes to assessment. Right? Okay. So, first group was 262.5. That's the average weight of people in that group. All right? What about program B? What'd you get for the average?
269.33.
269.33. Confirmation? Anybody get the same number? For the second group. You're doing it right now.
Yeah, I got the same block.
Oh, you didn't have the same blocks, so your numbers aren't the same. Okay.
I got the same.
262.33. Other people, you got a different. What'd you get? You got the same? Okay. You're shaking your head, Brandon. It's
269.
269.33.
Just 269.
You just got 269.
I probably messed up. Well,
Let me.
Okay, then do it again. We have to have consensus. We have multiple teams of math people, so if you've got the numbers, do it again.
I just got 269.
Even. Okay. And you just did it again and you're sure it's right. Okay. Huh? You just did it again and you're sure it's right. Okay.
Maybe though.
That's right.
Yeah.
Okay.
The same.
It's 269 and you got 269.33?
Yeah, wait, what did I do?
I don't know. Double check your numbers, compare them to hers, make sure you guys have the same thing. 269? So all the people except for one who got .33 agree it's 269? You got 269 again? See? Vindicated.
Oh, okay.
Got it?
I made a typo.
Typo, see? Now's the time you want to know.
Yeah.
Okay. 269. Sorry I have to write it in that weird split way, but it's because the C in the middle of the board. All right, now the control group. Now the control group. What did we get for the average for the control group? 279.17. We have multiple people. You got that? Other people who have been silent are now nodding. Tell me again, 279.17. Okay. How's that look? Does that look about right? We see some nods. Okay, good. So, now let's think about this. We're doing a study about weight loss. And we're looking at the average starting weights for our groups. Look how much variation we have between this group, program A, and program C, right, the control group. Between program A and the control group, look at the difference. 17 pounds difference. That's a lot. You ever tried to lose 17 pounds? That's a big difference. Also, the heavier you are, the easier weight comes off in the beginning, the harder it is to lose as you get closer to your goal. So, remember, our number one challenge when we're doing it between subjects design is creating groups that are similar enough to compare in a meaningful way. These groups aren't as similar as we could make them, starting off. They're rather different, in fact, in terms of something very important, and that's their starting weight. And if we're measuring weight loss, their starting weight really matters. So, as an alternative, let's see what happens if we intervene a bit and try to help random assignment do its job. Because random assignment's doing okay, but it might be able to do a better job. So let's see if we can help it a little bit. All right. So now what we're going to do is matching. Now we're going to do matching. And matching involves the same random assignment procedure, but before we implement that procedure, what do?
Highest to lowest.
Highest to lowest, right? We need to put all the people in order according to some matching variable. And the completely reasonable matching variable to use is their weight. That's what we care about, right? So let's put them in order first, from highest to lowest, heaviest person to lightest person, and create our different groups. Okay? So, who is our heaviest person?
Person 1.
Okay, so tell me what the person's weight is.
313.
Okay, 313. Okay, who's the next heaviest person?
311.
Okay, who's the next heaviest person?
301.
Okay, Those are gonna be, that's gonna be our first group, okay? First group. All right, tell me the next three heaviest people.
300.
300,
293.
293,
292.
292, okay? The next three heaviest people.
288.
288,
280.
280,
277.
277. Oops, sorry, I'm getting a little off. Okay, let me fix that. I'm getting slow. 288, 280, and 277. Sorry. Okay, next. Who are next people?
275.
275,
269.
269,
262.
262. Okay. And our next three.
256.
256,
253.
253,
247.
247. Okay. And our last three.
234.
234. Okay.
215.
215
And 198.
and 198. Okay. So what we've done now is we've put them in order. We've matched them. We've created matched groups. These people all rank as the most, or as the heaviest. These people are the lightest. Each one of these groups is made up of people who are as similar as possible in terms of their weight. Okay, given who we have to work with. Now, did you use the same blocks? Same blocks? Okay, so that was A, B, C. Tell me them again.
BCA.
BCA,
CAB.
CAB,
I don't know if I could do one.
BAC.
BAC.
okay?
CBA.
Okay?
ACB.
Okay, now, is it okay to use different blocks than those, or use the different order of those blocks? Yes. Makes absolutely no difference because all the orders are random orders, so it doesn't matter which order you use them in. Okay? It just so happens these were the ones we picked last time, so some people have used them again. They're perfectly good orders. There are other orders that are fine too. So as long as your procedure was the same, it's okay if your numbers are exactly the same. All right. So now if it's A, B, C, that means A, B, C, right? Okay. So A is 313, B is 311, and C is 301. What about this one? Who goes in A now?
292.
292. Who goes in B? 300. Who goes in C? 293. Okay. Who goes in A here for CAB?
280.
CAB is going to be 280. Okay, who goes here?
277.
277. And here?
288.
288. Okay. Who goes here?
269.
Who goes here?
275.
Who goes here?
262.
Who goes here?
247.
CBA. So A is going to be the last person. B is going to be the second person.
252.
And this is going to be the first person. 256. Okay? And ACB. So 234,
198.
198, and 215. Okay? Does everybody know where all those numbers came from? Do you know why we put them where we put them? Does it make sense?
Perfect sense.
Okay. Brandon, are you agreeing with me? Okay, I'm just checking. We're over there doing mouth shapes. I'm not sure if that means I have no idea what's going on, or got it, or I'm playing with my nose ring. Okay, there we go. I just was checking. Okay, so if we have these numbers, what do we get for our means this time for program A? If I add these numbers for program A and take the average, what do I get for the average for program A now?
272.5.
Is that right?
Yeah.
Okay. Yeah, we're good? Okay, what about program B?
269.
269 even?
Mhm.
Okay. And wasn't it the same as last time?
Mhm.
Isn't that weird? That like two totally different orders could give you the exact same average? That's kind of cool. Okay, and what about the control group?
269.17.
269.17? Okay, how much better did that do at getting groups that were close together?
A lot better.
A lot better. Right? Now our biggest difference is between 269 and 272.5. So we're not talking a 17-pound difference anymore. Now we've got like a 3.5-pound difference. And with some additional tweaking, you might be able to get it even closer. So matching is really helpful when you have small samples. Like only 18 people in your sample is not very many. Typically we want at least 30. We can get 30. And 18 is not very many to divide across 3 groups. So we'd like to have many more than 6 people per group. And random assignment can't do its job as well when samples are small. So it's not it's doing what it does, but it can't work the odds quite so well. So then that's when we intervene with things like range restriction or matching or something like that. But now, next question then. Erase that. It says, so compare the results. Which strategy you think worked better? And your answer should reflect the data you got, right? If for some reason, the way you did it, you actually got numbers that were closer together with the straight up block randomization than the matching, then your interpretation should be straight up block randomization was fine. Matching didn't give me that much more of a benefit. I don't think it was worth the intervention. But if the matching gave you much closer groups, then your answer should be matching did a better job of creating groups that were similar to start off with, which is important when doing a between subject study. So how do you guys feel about that problem now? You got it? Does it make sense now? Okay. So you've answered the questions you had about that problem? Okay. No, it was all right. Remember, this is the time when we do these problem set reviews. If there's something we've talked about that you don't get, shout it out, because we want to make sure everyone is ready to go into the test with good information, and none of the terms we're shouting out sound like, what? What do you mean matching? Because that's showing up on the test. I can guarantee you matching is showing up. Okay. Now this last question required that you actually read the textbook. There's always at least one question on the problem set that's about stuff from the textbook, because at this point I expect you to be able to extract information from the textbook on your own. I'm not going to tell you every single thing because I can't. We have to talk about lots of other things. So let's talk about these different cases and make sure we understand what these different terms mean. All right. I see people with their books out, going to check their references, make sure they've got this, okay? So here we go. What do we mean when we talk about a weak manipulation? What is that about? Yeah.
It's when there's a change in the independent variable is so insignificant it doesn't really affect the study at all.
Right. So if I wanted to do a study where I was going to compare if students did better on a test if the room was 60 degrees or 58 degrees, what do you think would happen? Nothing. Because even though I did a manipulation, even if I randomly assigned half the students to the 60-degree room and half to the 58-degree room, the chance that they would respond differently under those circumstances is pretty much none, right? 2 degrees is not enough to create a meaningful difference. Not at that temperature. Now, if it was even if it was between 0 degrees and -2 degrees, it probably wouldn't matter because you'd all be freezing at that point. Or if it was between 80 degrees and 78 degrees, it still wouldn't matter because everybody'd be hot, right? There's not enough difference. Now, if we did a change of 20 degrees, where one room was 50 degrees and one room was 30 degrees, we've all been in those 30-degree rooms. They always show up on Georgia State campus in the summer, right? Not in the winter. In the summer, when something about air conditioning in the South, I don't know what it is, but it's always like it's either on Arctic or broken. Right? It's one of those two settings. Am I right? This is my experience. Okay, so someone else give me another example, because I asked you to come up with your own original example. Yeah.
Well, I was about to say what you just said about the air conditioning would be
Okay.
an example, but
Okay.
like one example I remember from the textbook was they were talking about adding like 3 drops of Tabasco sauce
Mhm.
versus 4 drops.
Yeah.
Or, yeah, I mean that's.
It might be a difference, but it's not a meaningful difference. It's like the difference between a numerical difference and a significant difference. You might have numbers that are numerically different, but just because numbers are numerically different doesn't mean the difference is significant. Little differences kind of don't matter sometimes. And if they don't matter with regard to the levels of the independent variable, you're talking about a weak manipulation. You haven't created groups that can reasonably be expected to differ from one another. So when you get a null result, you can't be like, it doesn't matter. Temperature of a room makes no difference. Well, yeah, not when it's 2 degrees. That's not going to do anything. 20 degrees, then we'll talk. Anybody got another example? You want to check? Yeah.
This may be bad, but
That's okay. You're right. It might be. It could also be great.
I said, I didn't really put it in the form of a study, but
Okay.
increasing taxes 1% may not change how a wealthy person acts. But if you did the same with people below the poverty line, you may see a very different reaction.
Because 1% of their income is a bigger. So if you talk about somebody who's really wealthy, and you compare raising their taxes from, 20% to 21%, how much they notice that is pretty minor. So that's a weak manipulation. But if you do that manipulation with a totally different group, like people who are poor, take away 1% of their paycheck that you weren't taking away before, and that can fundamentally change what they're able to do. So again, the nice point about that is that with a certain population, a manipulation might be weak. With another population, a manipulation might be strong. And so the issue is thinking about the manipulation in that population. That's important. It's not just that automatically 1% is not important. It's proportion, right? And when you think about how much that means for what they have. Oh no, I have to give another $250,000 in taxes that I'll never notice because I have so many thousands of dollars. Versus I have to give up another $1,000 and now, or no, I have to give up another $100 and now I don't have food. Right? That's a really different situation. Okay, so weak manipulation, good. There could be situations where a change in just 2 degrees might be fatal. Right? Maybe you can stay alive at a certain temperature, and once you get below that other temperature, you're going to die. So 2 degrees isn't always negligible, but in the situations we were talking about, it was negligible. Okay, good. Anybody else want to throw out their example? See if they got a good example? See, it wasn't bad, it was good. So yay. Be brave. Scientists all have to be brave all the time. Okay, no more examples? Okay. What about an insensitive measure? What's an insensitive measure? Brandis?
When you operationalize something that doesn't correctly measure what you're supposed to measure.
Okay. Well, it might correctly measure it, but it might not measure it in a meaningful way. So, for example, this has to do with dependent variables. Say you're measuring, I'll do a weight loss study again because we just did a problem about that. Say you were looking at the different weight loss plans and you're doing weekly measurements and you're doing measurements in 5-pound increments. I don't know how many of you ever tried to lose weight if you were really heavy. I was really obese as a child. And so when I was 13, I weighed 250 pounds. And you don't lose weight in 5-pound increments. If you're on a plan like Weight Watchers or something like that, I mean, they might say, lose 5 pounds on your first week, but you don't lose 5 pounds every week. Right? Just like you don't gain 5 pounds every week. You gain weight slowly over time, and you lose weight slowly over time. So you might lose 1 pound or 2 pounds a week. But if you're measuring their weight loss in 5-pound increments, what's going to happen is, week 1, they lost 5 pounds. Great. Next week, they lose 2 pounds, it counts as no loss. The next week, they lose 2 more pounds, it counts as no loss. The third week, they lose 1 pound, okay, now they've lost 5 more pounds. So it looks like they're losing weight, not losing weight, not losing weight, losing weight, right? So it's not accurately reflecting the steady progression of the weight loss because the unit that you're looking at is too big. It's too insensitive to the level of change. So when you set up your dependent variable, you want to make sure that it's sensitive to change at an appropriate level. If you're looking at weekly weight loss, setting it at pounds makes a lot more sense than setting it at 5-pound increments. Similarly, you don't want to have your measure be too sensitive. You don't want to talk about weight loss in terms of ounces, because people don't typically lose weight in terms of ounces either. Now, if you were talking about infants, weight gain and weight loss in terms of ounces is fine. If you're talking about a newborn, I don't want to be talking about a newborn baby's weight loss in pounds. That's bad news. That's DFACS territory. That's like a baby. The baby is gone, right? That's DFACS territory, right, when you're talking about that. You don't want babies losing weight in pounds. So you want to make sure that your measure is appropriately precise to detect the relevant change. And if your measure is insensitive, it means you've set the meter too broadly. You're measuring in too big a swath, so you're actually going to miss change that's informative. And just think, say you are trying to help people lose weight. If you tell them every week, like, this week you did great. This week, oh, you didn't lose any. This week you didn't lose any. By the third week, they're starting to feel depressed because now they have 2 weeks of no loss compared to 1 week of loss, and they might quit. Whereas if you could say every week, you're losing, you're losing, you're losing, you're losing, they respond positively, right? So you have to make sure that your measure is giving you an appropriate degree of precision in terms of feedback. Not too big, not too small. All right. Next one, measurement error. So now can I just make a note here before we jump into this discussion? Every measurement, every single one, everywhere, all the time, in every single study, has error. Okay? Measurement error is not something you can avoid because people aren't perfect, measurement devices aren't perfect, equipment wears out, equipment can be poorly calibrated, or the calibration can just wear off, or the calibration might not work. Okay? People misread things. So you can have all the good intentions in the world, and you can be doing everything as well as it can possibly be done, and there's still going to be some error. And part of that is because when you gather data from a sample, that sample does differ in some ways, small or large, from the population that it was taken from. So you're going to get data from a sample, and it's not going to perfectly match exactly what you would find. And some people think about that as measurement error, right? You mismeasured the population because of the sample. Well, every sample differs in some way from the whole population. The only way you're going to get data from the whole population is if you get data from the whole population. And even then, you can gather data from the whole population. And because of those other things we talked about, that people are people, that equipment is equipment, and that stuff happens, you're going to get some error. So error can't be avoided 100%, but it can be minimized as much as possible. You want to keep the error down because the presence of measurement error is going to contribute to those two types of error we like to avoid, type 1 and type 2 error. The more measurement error you have, the more likely you are to commit a type 1 or a type 2 error. And we don't want to do that. We do want our results to accurately reflect what's happening, although they might be a tiny bit off here or there. A little bit off here or there is okay. If you're driving on the highway, the speed limit's 55. If you're going 54 or 56, nobody's going to pull you over. If you're going 85, they might. If you're going 105, they're totally going to get you because you're a super speeder and they can get you for like a $500 ticket. So a little bit here and there, and that's why they won't bother to pull you over if you're in with like 7 miles of this posted speed limit, because they can't be sure their equipment's accurate enough. You could argue that the equipment is not accurate enough, and that it could actually have given you a faulty reading. So as long as you're within like 7 miles, so 55 means 62. Just so you know. But don't go to 63, because then you're probably out of the range. Okay. See, research methods gives you handy tips for living. It's not just about science. It's about life. Okay, so tell me about measurement error now. What kinds of things might add to measurement error? No ideas? I can sit here forever. Yeah, Brandon.
Okay, I picked IQ and
Okay.
The cultural bias. You could measure IQ based on analogies that certain members of the population wouldn't get, therefore the data would be skewed.
Sure. So you can choose to measure things in a way that doesn't. That would be one thing you could do. They've said, for example, when they've done IQ tests on gorillas and chimpanzees and bonobos who use sign language, they've tried to show that they're not smart enough to use language. Then they show that the IQ tests are actually biased towards humans. For example, if you ask them a question like, which of these is a good thing to eat, and it shows them pictures of like an ice cream cone and a flower and a rock, and the gorilla picks the flower, which they actually like to eat, they get marked as wrong. But they don't eat ice cream cones, but they eat flowers. But it says they use the standardized questions, and supposedly that's wrong. So that's just an example of, right? So then you say, oh, well, the gorilla's not very smart. No, the gorilla totally understood the question. The gorilla answered the question in gorilla culture. And in gorilla culture, the flowers are delicious. I personally also like to eat flowers. There are some very delicious flowers. They're very nice on salad. It's very pretty. But you don't eat flowers. Okay? So I'm not going to like walk down the street and pick a flower and eat it. Not that weird. Weird, not that weird. But, you know, so yeah, you're right. So you could, the way you operationally define something can lead you to get measurement error. You define it in such a way that it has a bias. And that has to do with human bias, right? So human bias, right? Researcher bias. You might have a cultural bias that is inappropriate. I mean, there were classic case of IQ tests, right? Where IQ tests were set up to ask questions about things that people from certain cultural backgrounds had no experience with, and so they were said, look how stupid they are. Look how low their IQs are. Because they didn't have any experience with those cultural things, so they didn't know how to answer the question. Because it's like, we don't even have that where I come from. How would you answer that question? You know? So, all right, give me another example. What else can cause measurement error? Is it just the people? Just the operational definitions? What else?
Just your instrumentation is broken.
Yeah, if your instruments aren't working properly, if they're worn out, if they're old, if they're not properly calibrated, any of those things could result in measurement error. Remember we talked about instrumentation as a threat to internal validity, right? So if your equipment isn't up to speed or it's not working properly, that's measurement error. Okay? Because it's giving you bad numbers. That if it were working properly, if it were properly calibrated, if it were not broken or worn out, it would give you different numbers. Right? Maybe more accurate numbers. Okay, good. We can also get measurement error if we gather too little data. So if you only, I mean, just as a totally arbitrary example, say you date your dating experience includes 3 people. Okay. My daughter has had 3 official boyfriends. She's 14. 3 official boyfriends. So far, there hasn't been kissing as far as I know, but still. 3 boyfriends. Okay. And if she were to make generalizations now about all of the male species based on those 3 13 and 14-year-old boys, I would probably have to argue with her that she needed to take a step back, not overgeneralize, right? Because I'm pretty sure that those 3 boys are not representative of all boys. And so, I mean, I can tell you, before she got to the 3rd boy, she was pretty sure all boys were idiots. Because she was pretty convinced the first 2 were. Because they made dumb choices. Like, got super jealous and possessive and stuff. And she's just like, no, can't go there. She's like, all boys are possessive. They're so selfish. And I said, just hold on, you'll meet a different boy and he will be, now of course, Ethan. Can't do anything wrong. Oh my gosh, he looks like the lead singer from Bastille. Oh, he's so handsome. Oh, he's so perfect. But you know, the same idea, right? You don't want to make, when you generalize from too few data, that's measurement error too. Because you're not getting enough data points to get a true picture of what's going on. Now, am I suggesting my daughter go out and date every boy she meets till she gets a good test sample? No. But the truth is that you can't make broad generalizations about any group of people based on your experience with 1 or 2 of them. Right? That's just bad decision making. So, same issue. I really hope my daughter doesn't watch these videos. She'll be like, I can't believe you talked about it. Like, honey, I've been talking about you ever since you were born. You've been part of class the whole time. Her whole life is probably preserved on YouTube somewhere. It's certainly on Facebook, like all of them. Okay, and situation noise. What is situation noise?
It's a 3rd variable that can disrupt the outcome of the the study.
Okay, so situation noise, a 3rd variable that can disrupt the outcome of a study. How does it do that?
And cause the variability within groups.
Okay, so it can make your groups more variable. Can you give me an example of something that might be situation noise? Yeah.
So you administer an inventory for depression in different colored groups.
Okay, that would be situation noise. So let's think about that. You give an inventory for depression. You're asking people how depressed they feel. If you administer that inventory in a room with black walls,
No windows.
no windows, and 1 light bulb hanging from the middle of the ceiling, you might get different responses than if you administered it in a room with soft pink walls, candlelight, flowers. Right? Same people, different situation, right? So there can be things in the environment. Let's think of a more practical example. Have you ever had to take an exam with somebody in the room doing this?
Oh, yes.
And the whole time you're just like, go. And they're sitting there and they're like, and then they realize, oh yeah, then they're like, they start doing stuff and they're like, why? And you're just like going, and it's getting gooier and gooier as the class goes on because they haven't blown their nose. And so by the end, it's like this kind of almost slurpy nastiness, and you're just like, whoa, you know, you're trying to concentrate on the material, and you're trying to focus, and you're just like, I do not hear you. And then it's quiet, and then you start to get that feeling like, here it comes, here it comes, here it comes. And even when nothing's happening, you can feel the snot just ooze, right? You're just thinking about, you know what I'm talking about? That situation. And I've actually had people who are like, I wanted to concentrate, but there was somebody in the room who kept going, the person right behind me kept going, and it drives you nuts, doesn't it? So, just as a note, on Wednesday, blow your nose. Bring tissues. I would rather hear you blow your nose in class than hear you sit through the whole class go, and have everybody in the room go, situation noise. Situation noise. Situation noise.
That's a good way to remember.
That's right. See, now you're never going to forget situation noise now, right? You know how it distracts you, right? So anything in the environment in which data are gathered that could add to the variability with which subjects respond. Could be that the room's too cold. You didn't mean for it to be cold, but it just happens to be really cold. That happens here too in the summer. Like I said, I'll be giving a test and people have to come in like a parka because it's so cold. They have to bring jackets to class and they walk outside and they're in t-top, in tank tops and shorts because it's 95 degrees outside with 90% humidity. But they have to bring a blanket and a parka to take the test because in the room it's like 40. Okay. Next, everybody okay on those terms? We're all right with those? All right. Next. Okay, for each of the studies described below, decide whether the study is subject to one or more of the threats to internal validity described in Table 11.1. So that's basically like the handout that I gave you, right? But it has more details. I love that table. That's a great table. It gives you nice examples and all kinds of stuff. Okay. Identify threats and describe how you could correct or prevent the problems by redesigning the relevant aspects of the experiment. All right, so first one. For his senior thesis, Jack is interested in whether viewing alcohol advertising would cause college students to drink more alcohol. Do college students need motivation to drink alcohol? College students changed that much since I was a college student? He recruits 25 seniors for a week-long study. Of course, seniors. All right. On Monday and Tuesday, he asked the participants to log into a secure website and record how many alcoholic beverages they had consumed the day before. On Wednesday, he invites them to the laboratory where he shows them a 30-minute TV show interspersed with entertaining advertisements for alcoholic products. On Thursday and Friday, he takes a follow-up measure. Participants log into the secure website again and record the alcoholic beverage consumption. Jack found that students reported drinking more after seeing the advertising. He concluded that the advertising caused the students to drink more. Oh, Jack, you really should have taken 3530. Because if you'd taken 3530 before you did this study, what would you know? What's wrong with this study?
No, we should have a
Huh?
comparison.
He doesn't have a comparison group at all, right? He has no comparison group who didn't see the advertising. So what does he not know? Huh? What happens if they didn't see the advertising? He has no idea how they would behave if they didn't see the advertising. That's a problem. So he needs a control group, right? That's a big problem. That's a basic design problem, okay? Because he has another issue. Let's think about asking people how much they drink over the course of a week.
He asked them on the weekend.
He asked them on Monday and Tuesday how much they drink, and then he asked them on Thursday and Friday how much they drink. Thursday! Ladies' night, hello! 3 drinks! Friday, week's over! Drinks! Right? Exams, it's like Thursday. Let's just think about this, okay? Monday, you're like, oh, crap. Hungover. Yeah, you're like, I'm not drinking, I'm hungover. From Saturday still. Right? Maybe from Sunday. A little bit of crazy post 12:30 drinking, right, on Sunday. So he asked people on Monday and Tuesday, and then he has them come in and shows them the advertising. Then on Thursday and Friday, he asked them again, is there any possible way he's going to get lower scores on Thursday and Friday? I mean, just think about it. We're talking about college seniors. What's the likelihood he's going to get lower scores? Very slim. So what can he do instead? What might be a way to... He didn't hold the day he asked the questions constant, right? It overlapped with the not having seen the advertising and having seen the advertising. So he put a confound into his study, right? The day of the week varies systematically with whether they'd seen the advertising or not. Also, you just think about general drinking behavior. People tend to drink more at the end of the week than at the beginning of the week. Just in general. So, how could we fix it so that it's not a confound anymore? What can we do? What can we do?
You have control group.
Right, we can add a control group so we can look to see if their drinking changes over time too, even not having seen the commercial.
Do consistent days, maybe like, let's just say you did the weekend, and then maybe next weekend after you show it to them.
Right. So you do, okay, so this Thursday and Friday, tell me how much you drink. Then next Wednesday, come in, look at the commercial. And then the next Thursday and Friday, let's see how much you drink, right? He needs to hold the days he gathers data constant in the week, not vary it over the course of the week, because people's drinking, unless they have an issue, right? I mean, there are people who are like, Monday, yes, Tuesday, yes, Wednesday, yes. You know, they're like, I don't need any help to drink, right? Or people who are like, it doesn't matter what day of the week it is, I don't touch the stuff, right? That's just not my thing. You hear people go, oh, I feel sorry for them. No, don't. All choices, those choices are all good choices. You know, I mean, well, not the drink every day choice, that's not the best choice. But, you know, some people aren't going to vary at all, but it would help if he had a control group. It would help if he had consistency in the days he gathered data. Both of those things would improve this study and get rid of the problems that we see. Any other ideas? Those work for everybody? Does it make sense why those two things would be helpful? All right, next one says, in a cognitive psychology class, a group of student presenters want to demonstrate the power of retrieval cues. Do you know what retrieval cues are? Okay, cognitive. Retrieval cues are things that you use to help you recall information. So when I give you weird examples like situation noise, what I'm doing is implanting a retrieval cue. So now the second anybody in the class goes during the test, your brain's going to go, situation noise. Right? So when you think of examples that help you remember a concept, what you're doing is creating retrieval cues, things that help you retrieve the information from your memory. So, first the presenters asked the class to memorize a list of 20 words that they read in a random order. 1 minute later, members of the class wrote down as many words as they could remember. On average, the class recalled 6 words. Second, the student presenters told the class to try sorting the words into categories. Color words, vehicle words, sports words, for example, as the words were read. The student presenters read the words again in a different random order. On the second test of recall, the class remembered on average 14 words. The student presenters told the class the experiment demonstrated that categorizing helps people remember words because they are able to develop rich mental connections to the words.
I had a question about this one.
Yeah. I have lots of questions about this one.
Did they repeat the same words, or was it a brand new set of words?
Same words.
Okay.
Yeah. That's the right question.
That's the struggle.
Yeah. What's wrong with doing the same words?
They already
They already heard them before, right? They already heard these, so that's an effect of testing, right? Or practice effect, right? Practice effects and testing effects, same thing, right? So they've heard these words before. This is an order effect, right? They've heard these words before. That's not going to fly, right? Because since they've heard the words before, it's not just the, oh, now think of them in categories. So yeah, they improve. But in fact, if you would have asked people, if you'd read the list a second time and asked them to generate the words back, even if you did it in a random order, they'd probably do better the second time anyway. Right? Just like when you're going through your flashcards or whatever for this class, the first time you get like 2 right, and then you keep going through it and you keep getting more and more right because you're looking at the same words over and over again, right? You get better every time. That's called learning. Right? That's what happens. So how can we fix this? Well, one thing we could do is use a different set of words, right? So we could change the stimuli. So you need another set of words that are comparably easy or hard to remember, similar length, similar familiarity, stuff like that. Okay, so you could get another set of words. Okay, that would help. What else could we do? Huh? You said split the class up?
You're testing them twice, right?
Mm-hmm. Everybody, this is a within subjects one, yeah. The first one was between subjects, the second one's within subjects, right? Yep. So what could you do?
one group just be told the words in the order and see how many they remember, and then have another group that's told to try and categorize the words and see how many they can remember.
Right, so you could change it to a between subjects design and make it so that they only hear the list only one time. That would also work, right? Because then you don't have to worry about the order effects anymore, because if you randomly assign them to either hear, like, okay, we're going to randomly assign people either stay in the room or leave. Half the people end up leaving the classroom. You tell them the list. Then, okay, you guys have to go leave. The other half comes in, and then you look to see how many of the two groups you remember. That would work. That'd be another solution, because it would get rid of the order effect. You could, you could try and have would a comparison group help here, do you think?
What would you not expose them to?
Yeah, I don't think a comparison group is going to be useful here. So a comparison group is not always the right answer. Right? I've had students go, well, if as long as you have a control group, you're in good shape. And I'm like, no, sometimes a comparison group doesn't help. So using different words is the most obvious one. You could also change the design from within subjects design to a between subjects design, and that would also solve the problem. Anybody have any other ideas? Yeah, Brent.
Just test them on different days.
You could test them on, put enough time in between that they probably don't remember the same words. So you could test them on one Monday and then test them a subsequent Monday, and chances are that they would have forgotten the words by that time, given that they heard the list very quickly. Yeah. I had teachers in elementary school who would do stuff like that. At the beginning of the year, they'd give you a test, like a handwriting test or something, and at the end of the year, they'd give you the same test. And of course, you never remember that you've done it. Then they'd give it to you as a present to show you how much your cursive had gotten better or something while you were 7. That's cute. Like in the beginning, you're like writing in big letters, 2nd grade, and then by the end of 2nd grade, you're like, oh, look, cursive. You're like, look how much you grew.
I have a question. We changing the amount of words, change like our studies outcome. Like,
Changing the number of
the
words.
number of words. Let's some people might get overwhelmed hearing like 30 words.
Well, that's part of what you're trying to do is look to see how many of the words you can remember, because you don't want people, if you want to say, okay, I'm going to give you a list of 5 words, because almost everybody can remember a list of 5 words, because we're able to take in information at roughly 7 plus or minus 2 units. So if I give you 5 words, you can recite 5 words and keep them in mind long enough to remember them. So 20 words is going to max out pretty much everybody. 20 words is going to max out pretty much everybody. So that way you can actually observe clear differences between the groups. So that's okay. All right. Any questions, other questions as you went back over this assignment? Anything else you still have questions about? Anything from the whole problem set? Yeah.
From this, can you give us some kind of examples of what's going to be on the test that actually the entire thing?
Yeah. On the test, you can expect, let's see, what kinds of questions? We do
short answer,
matching, multiple choice, fill in the blank, short answer. So I might ask you multiple choice questions. I can guarantee that at least one of the questions on the test will come from the problem set. Guarantee it. If you know the problem set, if you know the bolded, underlined terms from the PowerPoint, that's really important. Make sure you know your vocabulary. If I've made a handout for something, make sure you understand the handout. So let's think about the handouts, right? I gave you handouts about, remember we were talking about chunks and lumps in Kroger, Kibble, and Purina 1? We talked about block randomization. We talked about matching, right? We talked about the differences. Then we did one, that was for between subjects designs, and we did within subjects designs. We talked about incomplete versus complete designs, and full counterbalancing versus partial counterbalancing. We talked about just simple block randomization versus A, B, B, A counterbalancing, right? Things like that. Make sure you know all those things. Make sure that you understand those handouts. Make sure you know, I gave you a handout about different threats to internal validity. I could ask you about that a couple different ways. On a matching question, I could actually give you an example of a particular type of threat to internal validity and ask you to identify what kind of threat it is. In a fill in the blank, I could give you an example and ask you to name the threat. Oh, that's regression to the mean. Okay. I could give you an example like those ones at the end and say, tell me what the problem is here. Fix it. Okay. So my tests are not all multiple choice. They do have, like I said, matching, fill in the blank. They could have some problem solving. So make sure you know things like how many possible random orders. If I tell you we're comparing 4 groups, and I ask you how many possible random orders of those 4 groups could we have, you should go, oh, I know that. 4 times 3 times 2 times 1 possible random orders. Okay? That's the extent of the math you're going to have to do on this test. Maybe take an average. Yes?
The practice quizzes that you have on Bite Size.
The what?
The practice quizzes that you have.
So I've posted the quizzes that are associated with the textbook chapters online. Those are solely for your practice to make sure that you understand the material and the chapters that are covered. They're not worth points or anything, but if you want to double check and make sure you're getting concepts from the book, those practice quizzes are good to use. Also, keep in mind, we have 2 fabulous undergraduate TAs who lead study groups, right? Did you guys have study group already?
Yeah.
I had one this morning. I'm having another one tomorrow.
Okay.
At like 6.
Okay.
I'm having one today at 4:30.
Okay, are you videotaping your study groups again?
I can.
Okay. Just you can post a study group in case people can't come, but they could watch the video if they needed to?
Definitely.
Okay. So any other advice that you think we should give them before we send them off? Oh, your note card. Don't forget, you get to bring one 4x6 note card with anything you want to put on it, handwritten on both sides. The only restriction is, well, first of all, it has to be handwritten, and you have to have enough room on there to put your name, the date, exam 1, spring 2015, 3530. Okay? But that note card, don't waste the opportunity, right? And let me also remind you, please do not think that one 4x6 note card can substitute for studying for this test. Because you can write definitions and examples on the note card, but that's not going to tell you how to apply them to new situations. You need to get it, not just, the note card cannot substitute for that marvelous cortex you have that's well trained over years of academic study. Okay? So prepare your note card wisely. I'm sure that both Chris and Javier can give you advice about how to make a good note card because they were both good at it. And use it. And remember, I assume you're going to have one and that you will have prepared one. Now, you don't have to. It's totally optional. But it's worth taking the time to think through the material well enough to prepare a good card. If you do your card in pencil, I recommend you be very careful because the graphite tends to smear. You might consider buying some cheap hairspray, like Idlenet or something like that, and spray it because it'll actually hold the graphite on. You can also at the art store get art supplies. They have graphite spray that will actually hold graphite pencil so that it won't smear. That's handy. I've also had students who laminated their cards. It's like a piece of art. Color coding can be very helpful. You don't want to just write and have everything be really confusing. Think about how you set up your card. You might go by concepts. Here's all the stuff I need to know about between subjects designs. Here's all the stuff I need to know about within subjects designs. Block it out. Think about it. Plan. Organize. Because, well, there's a couple reasons. First of all, if during the test you have to refer to your card, you need to be able to find what you wrote. If you wrote it so small and in some arbitrary place, you're going to be like, where is it? Oh my God. It's not going to help. Okay? So think about where you put stuff. Also, the more you think about what you're writing and the more you organize your card, the more you really think about what you know and what you don't know and what you need to explain to yourself and that kind of stuff. When you get to the test, chances are you will need your card less. Right? Preparing the card is actually a study tool. Using it is a comfort mechanism. Right? Because everybody's like, 35, 30, oh my gosh, I have to pass this class. Well, you have it. So, save a line or two on there for a positive, inspirational message. Yeah, you can do this. I had a student whose child wrote a mail. You can do this, Mom. It was super cute.
I drew pictures of my cats on mine.
So, I've seen Bible verses. I've seen all kinds of things on those cards. Whatever. Remember, we're just trying to get through with positive frame of mind, right? Also keep in mind, you turn your cards in to me and you do not get them back. So, before you come to class, break out your phone, take a picture of your card, both sides, so you have the picture, because when it comes to the final exam, if you want to go back and look and see what you wrote before,
You'll thank us later.
yeah, you'll have the photos to look at, and that will help you pick some things. Okay? So your card actually turns out to be a good study tool for the final, but you have to take a picture of it. Okay? Any other things we can think of? That's about it.
The videos.
Watch the videos again. They're really helpful. You might go through and try to do some of the problem set problems without looking at your notes. One of the things I recommend is that you prepare your card and then go through and try to do the problem set without looking at anything else but your card, and see if you can do it. That's a good way to tell if you're on the mark. All right, go for it and be awesome.
Yeah, and check on the discussion board. We have some tonight, tomorrow. Yeah.
Okay.
Oh yeah. So.
It's gonna be in the library.
Yeah.
Okay.
Yeah, and the room number should be on there. So yeah, just look for it on the discussion board, and you'll see like both of our times and room numbers. And yeah.
So you think you got this? Dragon Gun!
Do you come to class on the test days?
Yeah. No, I usually, let's ask her, but usually it's